How's it going, guys? Vlad here, and welcome to the extended version of the 7th tutorial in which we're going to discuss button debouncing. So before we get into the actual debouncing, I would like to discuss what is button bouncing, which we're trying to counter through the two methods that I've mentioned in the original tutorial. And by the way, if you haven't seen that, the link is going to be down below, so feel free to take a look at some of the Arduino implementations in which you can debounce your buttons. But let's go into the theory. So let's start off by an example. So let's say you have a ball, right? Just a simple soccer ball, rubber ball, basketball, and you decide to drop it towards the ground. So what is going to happen? Let's draw this as the ground. So I'm going to make it a nonlinear motion. So if you've guessed that the ball is going to follow basically this pattern, so it's going to start bouncing on the floor, you are absolutely correct. So how does this relate to the button? Well, actually, when you push your micro switch, so you have two leads, right? And something like this, your switch may be different from my drawing. You are creating the same type of effect on a very short period of time. So what I mean by that is that during a microsecond or a very, very short, unnoticeable to the naked eye time, when this portion of the button touches your contacts, it is going to bounce. So what that means is it's going to go up and down. It's going to open and close extremely fast. So let's take a look at some of the graphs which you would expect to see from such a device. Alright, so in an ideal case, so ideal, which would not require any button debouncing, you would have something like 0 volts, and then you would switch basically from low to high instantaneously. So this is, the button is not pressed, and here it is pressed. So imagine this being the time scale. So as soon as you hit the button, it's going to shift your voltage from 0 to 5 volts. In the real world, so real case, what you should see is this is your 0. As soon as you push the button, your voltage is going to go high. Then because of the bouncing, it's going to go back to low, go back to high, low, high, low. And once it stabilizes, it's going to stay high. So this period of time, this is your bouncing. And typically this time is defined within the data sheet of a button, and they're going to tell you what's a safe time for this particular button. So what this causes on the microcontroller, so obviously you read a low here in the case of an Arduino, then a high, then again low, high, low, high, low, and then high. So what this creates is that because your Arduino is much faster than the button itself, it's able to detect these spikes and these low downs and basically trigger your condition extremely fast. But you don't want that. You want to see the transition between low and high. So that's what causes the main issue with button bouncing. So let's take a look at the countermeasures in hardware and software and see how they interact with this case right here. So in case of software, what you want to achieve is that you need to get enough certainty to make sure that it is a logical high, so that a transition happened from 0 to 5 volts. So when you call out those multiple checks, what you're actually doing is increasing the time span of your check. So for example, let's say this is your distance, right? So 2.5 cells on my paper. So let's say you start checking here. So you start off at this exact moment. So you start checking. So here you have a high, and at some point you go back to low. So you eliminate this case. Once again, you get here, and again you get a high. So you start checking. Everything's fine. Everything's fine. And you can see that this distance is shorter than this. So you drop it again. You keep going. This is still low. You get here. Once again, you get a segment that is shorter than your check time, so you reject the situation also. Keep on going. Finally, you get here, and in this case, as you can see, you've checked for at least 2.5 squares, as it is here, so you can confirm that you do have a positive read on the high. So that is how you measure with the software. So as I mentioned in the main tutorial, if you make it too short, so for example, if you make something, instead of this, you select something like 1 cell, you may get a positive read somewhere here, right? Because as soon as you get this short high, your Arduino will confirm that you did get a high, but then it will go back to low and switch back to high, low, and high. So you have to really be careful with what's the time of your setting and what's your certainty. That basically determines the length of your checking time. In terms of hardware, if you insert a capacitor parallel to your button, as you know, the capacitor is going to charge much slower, which means that you need to give it some time in order to actually get to that 5 volts. So what happens is, when you start at 0 and you switch the button, let's say here you trigger your button, as soon as it starts charging the capacitor and then bounces back, you're going to have a discharge, right? So as you increase those bouncing times, you should see something like this. So it is bouncing, but it's not allowing the voltage to go all the way up until at some point it does cross this threshold, which is, I've explained this in the first tutorial. The Arduino needs at least 4.2 volts in the 5 volts mode to detect your basically high to low. And this is in the data sheet in the electrical characteristics. So as you can see, this capacitor is going to prevent these spikes all the way up to 5 volts, and you're going to get this sort of smoother transition, and it's only going to transition obviously based on your capacitor value. It's going to transition much slower, but at the same time you will detect that full transition much more accurately. So hopefully you've gained some knowledge in terms of button debouncing. If you have any questions for the software and hardware implementations, let me know. Also, I'd be curious to see what kind of projects you're currently working with where you've actually implemented this, because button debouncing is usually critical in transitions, but it's not critical when you have for example, you press the button down and you hold it down and you have a process that goes on during that time. So in that case, button debouncing is not as critical. So yeah, leave me some comments. Let me know what you guys think. Thank you for watching. Bye.